Hello everyone, let's start our discussion about JSLint. The extent to which JSLint performs the code quality check can be altered using the JSLint options. The Boolean options present on the web interface allow you to toggle between the choices of default, true, or false. So if for a given option no value is explicitly chosen, then the default or implicit value will be considered. All of the Boolean options in JSLint are false by default. This in effect means that JSLint is as strict as it can be. Now JavaScript's dependence on global variables is its biggest problem. If a variable is not explicitly declared, generally with a var statement, then JavaScript assumes that the variable was global. It is necessary to use a var statement to declare a variable before the variable is assigned a value. JSLint recognizes a global directive that can indicate to it that the variables used in this file were defined in other files. The directive can contain a comma-separated list of names, with each name optionally followed by a colon with either a true or a false value. Some globals can be predefined by us. Let us analyze the various options given by the JSLint tool available through the web interface. Let's first take a look at all the assume options. The first option being a browser. A browser option allows us to predefine the standard global properties that are supplied by web browsers, such as a document or an event listener. Another option can be console, alert, dot dot dot. This option should be used to predefine globals that are useful in the development mode. However, its use should be avoided in the production mode. The node.js, the couchdb, the node.js, and the Rhino options are selected to predefine globals provided by the couchdb Rhino environment or the node.js environment. The stop on first error option should be set to true if we intend the scan to stop on the first error. Now let us talk about the tolerate options. There are a lot of tolerate options, as we can see. All of these options are into the tolerate options. The assignment expression option should be set to true if we wish if the assignment should be allowed outside of the statement position. The bitwise operators option should be set to true if we wish to allow the use of bitwise operator. Let's talk about Google closure. Now, Google closure is a standard for annotating the JavaScript code for the compiler. The Google closure option should be set to true if Google closure annotations should be allowed. The continue option should be set to true if the continue statement should be allowed. The equal to and the not equal to option is set to true if these operators should be tolerated instead of using the triple equal to and not double equal to. Let's talk about the eval function. The eval function provides access to the JavaScript compiler. This is sometimes necessary, but in most cases it indicates the presence of extremely bad coding. The eval function is the most misused feature of JavaScript. The eval option is set to true to allow the use of eval. Another one we can talk about is the unused parameters option. This option is set to true if we do not wish to see the warnings for unused parameters. Another interesting one is the to do comments option. This option is set to true if the comments starting with to do should be allowed. Last option for the tolerate options is the messy whitespace option. This option should be set to true if strict whitespace rules are supposed to be ignored. Now the last three options where values are expected are the indentation option, the maximum line length option, and the maximum number of errors option. For the indentation option, the default value is 4. This indicates the number of spaces used for indentation. The second being the maximum line length. This indicates the maximum number of characters permitted per line. The third option is the maximum number of errors. The default value for this is 50. This indicates the maximum number of warnings to be reported. After looking at all these options, let's discuss a bit about the comparison of JSLint and JSHint. While using JSLint throughout the semester, we also came across this tool JSHint, which basically is a less stricter version of JSLint. So we did code quality check for some files of the projects using JSHint as well. JSHint was developed to get a version of JSLint that is more community friendly. JSHint does not have all the customization options as JSLint. JSHint is a bit more lenient on a few stylistic and minor syntactical options that JSLint is more strict on. Also, JSHint provides a different form of output. Along with giving the errors an approximate location, it also gives a report on the number of functions, average number of lines in them, the largest functions, and a few more things. Let us try to analyze these two. I'll try running the code on using the tool JSLint. When we hit JSLint, we can see the list of the errors that come up. As we can see here, only 9% of the file was scanned before the maximum number of errors was reached and the file was stopped scanning. Here JSLint provides a lot of expected errors, such as expected if at column 9 not column 5. So there are a lot of errors which are more towards good programming practice rather than being syntactic errors. So it is a rather more strict tool. If you run the same code on JSHint, we can see it gives us there are 33 functions in this file. Function with the largest signature takes 3 arguments while the median is 1. The largest function has 38 statements in it while the median is 4, and all these along with requires this 3 unused. We get the proper analysis of the code using JSHint as well. So basically JSLint is the more stricter one and JSHint is rather the lenient one. If you need the highest / most strict code quality check, then JSLint is a good bet, whereas if you want a bit of flexibility and more features along with the code quality check, then I guess JSHint is preferred. Now let us continue our discussion of the output of JSLint on our selected projects.
Now let us continue our discussion of the open source projects. We used the command line tool for running JSLint on our projects since it was easier to run lint on multiple files from the command prompt, and most of the style warnings are turned off by default on command prompt. Now let us run JSLint on one of our project files and see the output. This command line utility uses cscript, a Windows script host, to run JSLint for WSH, which stands for JSLint for Windows Script Host. I'm running lint on the Sudoku file. Now, as you can see, there were a lot of errors thrown. I have taken the output of this on a notepad. Let us examine the errors. Yes, this error use the object literal notation. This is a new error and it is on line number 120. So let's look at the source file. So on line number 120 we can see this particular line, which is wrong according to JSLint. Let's see if we can rectify this. So we can see that with just one line of code, JSLint throws about 4 errors, including errors with space, where you didn't have a space between the object and is equal to and new. And finally the error which we are actually interested in, use the object literal notation, open brace and close brace. So let's try to fix these errors. Okay, this is how you resolve the object literal notation error. You just use open brace and close brace instead of the new object directive. Let's look at the other errors. This error is also a new error. unnecessary semicolon which is on line number 180, 198 and column number 240. Okay. Yes, here we can see all these braces closed followed by a semicolon. This is considered to be bad form because this is unnecessary code. Semicolons are not required after block statements or function declarations. Here they are present and this is why JSLint is unhappy about it. Now let's look at the next error. We can see this particular error repeated many times. Don't make functions within a loop. We can see them repeated 3 or 4 times. So, and this is on line number 198 and column 243, which was the same line which we saw before, where we are calling a function getSolution message multiple times. So the problem here is the functions are within a loop. When a function statement is seen within a looping construct, say a for, a while or a do while, then this particular error is thrown. The error is raised because unexpected behavior might be caused in some occasions. The root of this problem is because JavaScript interpreter creates an instance of the function per loop iteration. This is done because the function object can be modified within the loop, and this can cause performance problems or unexpected behavior. So this is something which has to be fixed. Let's look at the next error message. This particular error message is new as well. Missing radix parameter on line number 236 and column number 146. So this is because of the parseInt function having only one parameter instead of two. So the parseInt parameter is supposed to have two arguments. The first argument takes the string which is supposed to be parsed, and the second argument is the radix, that is the base system in which the string is supposed to be parsed. This error is raised when you have only one argument. This can lead to undesirable results if the radix is not specified. According to the ECMA5 specification, the parseInt function produces an integer value dictated by interpretation of the contents of the string argument according to the specified radix. Leading whitespace in string is ignored. If radix is undefined or 0, it is assumed to be base 10, except when the number begins with the character pairs 0 small x or 0 capital X, in which case a radix of 16 is assumed. But in older versions of ECMA script, if a string begins with 0, the octal base is assumed, and if you have a parseInt with a string, say 012, you might get a return value of 010 instead of 012, which is unexpected results. The fourth project, JQuery, did significantly better, with all files being completely scanned. Errors thrown were mostly about not using an if statement within a foreign statement, or not using the triple equal to for type-safe comparisons. But there were a few errors which we suspect was due to some sloppy coding. One of the errors was due to this file, outro.js, which consisted of 2 lines with just a closing brace and 2 closing parentheses. This caused an error which said expected end of file, but instead saw a closing brace. A similar error was caused in another file, intro.js, due to this line. Here we have an open parenthesis which is never closed, which causes one error. Then there is a brace which is opened, which is never closed, which causes another error. and then JSLint is looking for a closed brace which it can't find, so it caused a third error. This, other than these errors, we did not find any significant problems with jQuery. This completes our discussion of all the 4 open source projects which intended to discuss. We spoke about JSLint first, the motive behind JSLint, how to use it on command line and on the website. Then we discussed about JSHint, its purpose, which is actually a fork of JSLint. Then we talked about Mozilla Together.js, which was validated using JSHint, which did the best amongst all our 4 open source projects in the code quality check. Then we spoke about jQuery, which also did well, where less than 1/3 of the files threw errors or warnings. Then we had the other 2 JavaScript projects which were not so popular, where code quality was not ensured by any of the code quality tools. Amongst the 2, Sudoku performed comparatively better, mostly because Sudoku was just one JavaScript file with 600 lines, whereas Draw2D was a much bigger project. This concludes our analysis of JSLint, a code quality checking tool. Thank you.